Welcome back to lesson 1 of term 6. So what we're going to do is we're going to have a look at the ionizing properties of the electromagnetic spectrum. So we're going to have a look at the 3 parts of the electromagnetic spectrum that will cause ionization, and also we'll find out what ionization is. Just before I move on, remember the slide with the red star of information that you will need to know. So for your exam, any slide without a red star are slides that information is just useful to you, and any slide with a blue box on are questions or tasks for you to complete. So here we have our first blue box. So these are the remember questions. Okay, if you need to stop the video, complete the questions, and we will resume momentarily. Okay, welcome back. Here are the answers. Number 1, the equation for wave speed is frequency times wavelength. You may have written it V equals F lambda. Number 2, the unit of wavelength is in meters. Question 3, the unit of frequency is hertz. Question 4, radio waves, microwaves, infrared, visible light, ultraviolet light, X-rays and gamma rays are the order of the electromagnetic spectrum from the longest wavelength, okay, or lowest frequency, to the shortest wavelength and highest frequency. And uses for infrared, you can have them for TV remotes, you could have them for sensors that turn on the lights, like security lights. Cooking, for instance, is also another use of infrared. Heat lamps. If you have young animals like lambs and stuff and they're cold, you can put them under a heat lamp. Okay, so let's now just move on to the lesson properly. Okay, the first thing that we need to be aware of is this is your first red star. What is ionization? So I'm just going to read through this with you. So the ionization is a process in which electrons in atoms absorb enough energy to break free from the atom which holds them. Ionization can also be the gaining of electrons by atoms. An ion is an atom with either a positive or negative overall charge. Okay, let's now break that down into what we've got. So ionization is the process in which electrons in atoms absorb enough energy. So for instance, if you've got a ultraviolet ray coming in and striking a surface where atoms are, what happens is that the electrons gain more energy from that ultraviolet light, and the reason that happens is because the wavelength is very, very short, down into the atomic range, and the amount of energy, the intensity, okay, of that energy is very high. Therefore, it's basically bombarding the electrons and giving them energy, so it's hitting them. So that ultraviolet radiation is hitting those electrons every wave that hits them, and basically they just get enough energy just to bounce out. Okay, now also what can happen is that you can have electrons that are floating about because of this process that then bond themselves to other atoms, and this can also become ionizing as well. And ionizing is basically the removal or the addition of extra electrons to an atom. And when that happens, they are called ions. And an ion is a charged particle, a charged atom if you like. And the only difference between a normal atom and an ion or charged atom is that the ion has gained or lost an extra electron. So if it's lost an electron, it will become positively charged because the charge of the protons will be 1 or 2 extra. If it's lost 1, it will be a +1. If it's lost 2, it will be +2. So it becomes positively charged. And if it gains an electron, electrons are negatively charged. Okay, so the atom will become overall negatively charged, and that ion would be a minus ion. And you can represent that by for instance, if we picked sodium, for instance, Na, if it loses 1 electron from its outer shell, it would become Na+. Okay, so let's just move on. So, the little bit at the bottom says, remember an ion from year 9 when you were talking about ionic bonding. All right, now this is where, as I was just saying, that you get sodium becomes plus, and if you were bonding that to the chlorine, chlorine would gain that electron and become negative, 1 negative, so that would be Cl minus. And when you put them together, because one's got a positive charge and one's got a negative charge, they cancel out each other. And that is where the ionic bonding comes from. This is also known as, if you really want to take this a bit further, Compton effect. A gentleman called Compton came up with this idea. It's also known as the photoelectric effect, which was what Einstein got his Nobel Prize for. Okay, so the parts of the electromagnetic spectrum that are ionizing, there are 3 parts. You have ultraviolet radiation or ultraviolet, you have gamma rays, you have X-rays, and you have finally the gamma rays. And they're in this order because this is the least energetic, this is the next energetic, and then this is the most energetic. In other words, this has the least energy out of the 3, this has the most energy out of the 3. Okay, and also you'll notice that the wavelength, as you move that way, also becomes closer together, smaller. The wavelength becomes smaller, and the reason that is it becoming much closer to the size of atoms and electrons and nucleuses of atoms, and therefore it has the ability to interact with particles much more easily. So here is a table showing you the non-ionizing. In other words, this side would be the heating effect. So all up to here is the heating effect. And then you have ionizing. So you have ultraviolet, X-rays and gamma rays. Okay. So as it says underneath, it damages, it can break bonds, it can damage DNA, and also it has its uses. So ultraviolet, if you notice at the moment, if you're outside a lot, you will find that you're starting to develop a tan, and that is from the ultraviolet radiation that is naturally occurring from the sun. And from the sun, there are 3 types of ultraviolet radiation. There is UVA, UVB, and UVC. Now, if you look on the bottle of sunscreen or sun cream, you will see that it says protects you against UVA and protects you against UVB. And UVC is not mentioned. The reason UVC is not mentioned is because it's absorbed by the upper atmosphere. Fortunately for us, if it wasn't, we would all be dead. So UVA and UVB, okay, also can be harmful to us. It can give you sunburn, okay, can also cause skin cancer and cataracts. Now, skin cancer is caused by the ultraviolet radiation damaging our skin. Okay, it's damaging it on a cellular level. So what happens is that the ultraviolet radiation comes in, it strikes the skin, it knocks the electrons out of various chemicals. Those chemicals then become what's called free radicals, which then interact with other chemicals within the body, and that's where you start getting the problems and why you get skin cancer. Now, if you have a question that asks you about ultraviolet radiation and what damage it does to your body, then you would state skin cancer. If you state cancer, the mark, you probably won't get the mark because they would see that as insufficient for that mark. All right, then you've got X-rays. X-rays basically have more energy than ultraviolet radiation, and most of the time these just harmlessly pass through us. But if you were exposed to a large amount of these, they have the same potential to cause damage to the body on a cellular level, breaking bonds, um, and can lead to cancers and cataracts and radiation burns, etc. So, for instance, you would only be exposed to that kind of level of radiation that would really do you harm by X-rays and gamma rays, that if you were exposed to something like a nuclear explosion or a nuclear accident like Chernobyl or Fukushima or somewhere like that. So you would have to be somewhere where there's a lot of radiation. Gamma rays and X-rays pass through our body about 200,000 times every day, and our body is quite able to cope with that and repair the damage. But you would have to be exposed to a lot of radiation for these. But these do have the higher energies. Okay. Ultraviolet light, okay, has lower energies, but we're exposed to more of it, and that's why our skin browns. Okay, that's the fundamental reason why skin turns different colors, is due to the levels of ultraviolet radiation about, and the amount that we're exposed to it. Okay, so let's just move on to the next one. Okay, so these two slides, you'll notice, have no red star on it. This one and the following slide have no red star on it. They're merely for information. Okay, so you've got ionization of molecules, so you can sit and read this happily to yourself. And also you've got general ionization of human tissues. Now, the thing that you need to be aware of is that ionizing radiation is harmful and potentially lethal to living beings. Okay, but some types have medical applications. Now, in the next lesson, you will be looking at medical applications and also other applications and uses of ionizing radiation and other parts of the electromagnetic spectrum. Now, the thing that you need to be aware of is that it's harmful. Okay, ionizing radiation, all right, is harmful to living things. We've just said that about, you get these free radicals, and if you look at here, it says ionization molecules can lead to radioisotope breaking chemical bonds and forming up highly reactive free radicals. These free radicals may then react chemically with neighboring materials, and even after the original radiation has stopped. And this is what causes harm, these free radicals. So you can also have more adverse health effects. Exposure to ionization may be grouped into two general categories. I found this information on the internet, and you do not need to know these names. Okay, you simply need to know that the ionization is harmful to tissues. It can cause skin cancer or inherited problems. In other words, if the DNA is damaged, then these problems can be passed on to offspring of people and cause you to have a mutation. And you can also click on the button here that will take you to mutations in Wikipedia. But basically, the things that you need to be aware of is that ionization can cause damage to DNA, to cells, and ultraviolet radiation can cause skin cancer or other forms of cancer or inherited effects. So it's worth probably just noting a little bit of this down, but you don't need to know any of these names. It's just for completeness that this information is here. Okay, so what you need to do now is you need to create a booklet that creates information about the types of ultraviolet light, risks from each type of ultraviolet light, precautions needed for each type, and health benefits from it. Remember to write in your own words. Please don't copy and paste. All right. You'll need a minimum of 150 words and reference the diagrams and sources used for this booklet. And the total marks is 20 marks. And 10 of these marks will be for the referencing carried out. All right. And you will lose marks if there are any cut and paste. All right. Because we can check that now. Thanks to Mr. Google. All right, so you might want to stop the video at this point and have a go at this. It's probably going to take you about half an hour, depending on how the quality of your work. But the better the quality, the more information you have, this will be a useful revision source for you later on this year and next. Okay, let's look at the next slide. Now, on the next slide, we've got the complete the assessment for this lesson now that you have finished the slideshow. Please make sure that you have finished the slideshow and that you have done the booklet before you do the assessment, because both those things will be useful to you when you complete it. Thank you for watching.